We want to write an assembly program corresponding to the problem on the slide. And the slide is saying that translate the following pseudocode expression to MIPS assembly language code. So we are given this pseudocode. How many lines? 1, 2, 1, 2, 3, 4. 4 lines. And our job is to transform these 4 lines to assembly code. And then what is saying more? Include code to ensure that there is no array bounds violation when the store word instruction is executed. So we see in the 4th line that S0 should be stored in an array, and the name of the array is JEP, and also the offset of the address is A0. So in order to store a value in memory, we use the store word instruction. So which one is staying here? So now it's saying that when the store word instruction is executed, then we need to check that there is no any array bound violation. So now we need to know, so what is array bound violation? Okay, let's read more. Note that the array JEP is an array containing 50 words. So we know that so here we have 200 space, and for every word or for every element, it requires 4 spaces, 4 byte, and we are given here 200 bytes. So we have 50 words or 50 integer values. Thus, the value in the register A0 must be in the range from 0 to 96. So in the array, so we have 50 elements, and the first element, so let's consider that. So we have the memory. Okay, so here we have JEP. JEP is indicating some cell in memory, and the first element is stored 1, 2, 3, 4 in the 4 cells. The first element, then the second element in next 4 cell. Okay, so that's how it goes. So if we have total 50 elements, then for the first element is 4 cells, and this starts with 0. Then for the second element, 0, 1, 2, 3, and 4. And that's how the fifth element will be stored in 196. So the value of A0 here, the index of the array, the value of A0 can be between 0 and 96. So if A0 is less than 0 or A0 is greater than 196, then it should be a problem. And so when some problem occurs, then we should jump to some other set of codes so that the user can identify that is a problem. So include code to ensure that the value in register A0 is a word address offset into the array JEP. So if an array bounds violation is detected, so what do we do? So if a violation is detected or the value in the register A0 is not a word address offset, then branch to the label error. So we are given a label error. So if A0 is less than 0, then we jump to error. If A0 is greater than 196, then we jump to error. Then how about that? So can A0 be 0? Yeah. Can A0 be 1? No, it shouldn't be 1. So A0 has to be divisible by 4, because for every element we need 4 cells, 4 memory units in memory. So we need to check if A0 is not divisible by 4, then it should also jump to error. So the 3 conditions we need to check: that A0 is greater than equals 0, A0 is less than equals 196, and A0 is divisible by 4. If any of the condition is violated here, then we should jump to the error. So now so let's write it. So what we're given here, dot data. Then the array JEP, and it has 50 elements or 200 spaces. Think that JEP has 200 spaces. Then dot text means the program code starts. Then in the JEP indexed by A0, it should be the S0 should be stored. Just double checking that I'm writing it correct. Yeah, JEP A0 equals to S0. Now we need to translate this piece of code into assembly. The first line is already assembly. The second line is already assembly. The third line is already assembly. But the fourth line, so in order to store some value in register into some memory, we use the store word instruction. So what we need to do here, so the corresponding of this this JEP A0 equals S0 is the store word instruction. Store word. And the value in S0 we are going to store. So if S0 is the value, and we are going to store this value in the JEP array. So we need the the location of the array, the address of the array, and we know that. So by using load address instruction, so we can find the location of the array, the address of an array. So now load word. So let's consider we want to store the address into in T0 register and the address of the JEP array. So now store word so S0 will be stored in the array, and that address is T0, and also offset is A0. Okay, so that's the corresponding pseudo code so of the very last line. But so we need to check a number of conditions here, that so if A0 is less than 0, then it's an error. If A0 is greater than 196, then it's an error. So if A0 is not divisible by 4, then that's also an error. So let's check. So if A0 is less than 0, so less than 0, then go to error. We are given this label somewhere. If A0 is greater than 196, go to error. If A0 not divisible by 4, then go to error. Now, so for this, each of the lines we need to convert them to corresponding assembly, and we already got them, so we don't need them anymore, because so only the remaining task here, so we got them as well. So only the remaining task is to convert these 3 lines so into assembly. So what can we do for the first line? So if less than 0, so there so we have its instructions. If less than 0, runs if less than 0. So if A0 is less than 0, then branch to error, and that's how so we implement the first line. Now for the second line, so if A0 is greater than 196, so there is no any instruction that can compare so a register and an immediate value, but there are instructions that can compare between two registers. So now, so first let's put 196 so into another register and load immediate. Let's consider T1. We have T1 and 196 in T1, 196. Now if A0 is greater than T1, then go to error. So now runs if greater than, runs if greater than. So if A0 is greater than T1, then runs to error. So that's how so we implement the second line as well. Now the third line, if A0 not divisible by 4, and how do we check if an integer is divisible by 4? If the least two significant bits are 0, then it's divisible by 4. And now we need to perform here an AND immediate operation, and let's consider that AND immediate, AND immediate, and we want to do it for A0, and we want to store it in T0, or probably, okay, so if we have used T0 already, so then we can use other registers, probably T5 or any other register. So T5 equals end of A0 and A3. Now so if T5 is equals 0, then A0 is divisible by 4. If it is not equals to 0, then it is not divisible by 4. So now we can change A0 not divisible by 4. We can change this one by T5 not equals 0. So if T5 not equals to 0, then A0 is not divisible by 4. So now how do we implement this one? So if not equals to 0, so we have instructions like runs if not equals to 0, not equals to 0. So if T5 is not equals to 0, then branch to error. And that's how so we implement the third line as well as the finishing of the program. And so we know that so now we need to have the store word instruction here. And so what we needed here, so we wanted to store the value in S0 in JEP A0. So now we have A0, and also we have the location of the JEP array, something that we did for T0, and we want to store the element in S0, so that will be S0, and the memory is T0, and the offset is A0, something that we already wrote. Thank you so much.